Assalamu alaikum wa rahmatullahi wa barakatuh. We are continuing with stoichiometry calculations. Um, we have a sum here that says carbon reacts with hydrogen to form methane. C plus H2 forms CH4. Now, what we have here is they asked us three questions relating to stoichiometric calculations. Now, the first question says if 24 grams of carbon was used, how much grams of hydrogen is required? Now, looking at that sum, we can see that we got 24 grams of carbon and they want how many grams of hydrogen is used. So this is a mass type of a sum. Now, looking at the next sum, it says how many grams of carbon is required to form 44,8 dm cube of methane. So this will be a mass volume sum because here we got mass and we got dm cube. And in the last question, we got 11,2 dm cube. If 11,2 dm cube of hydrogen is used, what volume of methane gas will be formed? So this is a volume sum. Okay, let's look at the first sum, the mass sum. So we got carbon reacting with hydrogen to form methane. And what we have to do first is balance it. And we got 4 hydrogen on this side. So we need 4 hydrogens on that side. So we need a 2 in the front of that hydrogen to balance the equation. Now our equation is balanced. So we are given 24 grams of carbon. And they want to know how many grams of hydrogen is required. So those are the relevant parts. It's important to identify the relevant parts. If 24 grams of carbon was used, how many grams of hydrogen is required? Now, when we're doing the shortcut using the mass method, we go to the periodic table. And from the periodic table, we see that 12 grams of carbon will always require. Now here you need the balancing numbers. The mass of carbon is 12. And you've got 2 into 1 hydrogen, that's times by 2. So we can say 12 grams of carbon will always require 4 grams of hydrogen in order for them to react completely. So therefore, we can see in our case, 12 grams of carbon will always require 4 grams of hydrogen. 24 grams of carbon, how many grams of hydrogen will be required? It will be X, and if we cross multiply this, 12 times X is 12X is equals to 24 multiplied by 4, and then we divide both sides by 12, and we can see that X will be 24 multiplied by 4 divided by 12, and that will give us 8. So X will be 8 grams of hydrogen will be required. So this is the first type of sum which we did in an earlier clip where we're looking at a mass calculation of the mass method of doing the first sum. If you look at the second sum, we see they say how many grams of carbon is required to form 44 grams of methane. So it says how many grams of carbon is required. So we look at number 2. I'll do it on this side. Again, I'll say C plus 2H2 forms CH4. The question says how many grams of carbon is required to form 44,8 dm cube of methane gas. Now this is a mass volume sum as we have mentioned. Now we look at the mole ratio, we see that 1 mole of carbon will form 1 mole of methane. That means we know the rule. The rule is 1 mole of any substance occupies 22,4 dm cube. So therefore, because we got 1 mole of carbon, it will form 1 mole of methane. If we got methane of 44,8 dm cube, then the number of moles of methane that we have is actual volume of a molar volume. So our actual volume is 44,8 and our molar volume is always 22,4, which is a constant, and we got 2 mole. So we've got 2 mole of methane. So if we got 2 mole of methane, therefore we can say that 2 mole of carbon will react. So to find the mass, the grams of carbon, we say actual mass is equals to number of moles multiplied by molar mass. And the number of moles we've seen is 2 moles, and the molar mass of carbon is 12, which gives us an answer of 24 grams. So that will be how we will calculate the number of grams of carbon that are required to form 44,8 of methane. To do the same sum using the mass volume method, we can say according to the periodic table 12 grams of carbon, or according to this, because our ratio is 1:1, 12 grams of carbon forms 22,4 dm cube of methane. But we have 44,8 dm cube of methane, and therefore we want to find the grams, which is x. And if we cross multiply, we see 12 times 44,8 is equals to 22,4 times x. And if you divide both sides by 22,4, you will see that x will be equal to 24 grams. So this is a quicker way of doing the sum using the mass volume method. Looking at number 3, the question that we have. If 11,2 grams of hydrogen is used, what volume of methane is used? So let's just write the equation again. We got carbon plus hydrogen, 2 hydrogen, forming 1 methane. And we are given, the question is, if 11,2 dm cube of hydrogen is used. So we got 11,2 dm cube of hydrogen. What volume of methane is formed? The volume of methane will be formed will be what we have to find. So here we see that we have a volume sum. So according to our volume ratio, if we look at our volume ratio, we can say 2 hydrogen will react with 1. 2 hydrogen always forms 1 methane. So therefore 2 hydrogen will be 2 times 22,4 will always form 1 methane, which is 1 into 22,4. So 2 times 22,4 is, we can say, 44,8 dm cube of hydrogen will always form 22,4 dm cube of methane. But we don't have 44,8 dm cube of hydrogen. We've only got 11,2 dm cube of hydrogen, and that's going to form x. And if we cross multiply, we see 44,8x is equals to 22,4, and we take 11,2 on top times 11,2, and we only want x, so we get rid of the 44,8. Therefore, if we work out x using a calculator, we see that we get 5,6 dm cube. You'll see that x is equals to 5,6 dm cube, and that will be the answer for the final question, which says if 11,2 dm cube hydrogen is used, what volume of methane will be formed? And the answer is 5,6 dm cube. So this is a typical sum which shows how to do stoichiometric reactions when we have mass calculations, mass volume calculations, and volume calculations. Thank you very much for watching.